This is the fifth and final session on the SAT Math substitution strategy, where you choose numbers to turn a problem into an arithmetic problem. If you want to try this on your own before looking at the solution, you can pause the screen now. In prior problems, there wasn't too much trouble in choosing numbers that met the condition of the problem. But some particularly difficult cases are when you have to make the left-hand side of an equation equal to the right. So let's take a look at this problem. A received twice as many votes as B for class president. If 96 votes switched from A to B, they would have received the same number of votes. How many votes did A get? Well, let's try it with some numbers. So we have A and B. Let's say B had 100 votes. That means A had 200. And if 96 switch, A has 104 and B has 196, which doesn't meet the conditions of the problem. And it would be hard to guess and check until we met that condition. So, but we can still use numbers to set up the algebra. So, and what I like to do is to put a question mark over my guess, because that's where the variable will eventually go. Okay, so you don't want to put 200 here because then you've lost where the variable goes. So how do we get 200 though? We did twice our guess. Okay, and then when 96 switch, so that's a constant of the problem. So we have finally A is twice the initial thing but minus 96, and B is the initial guess plus 96. Okay, so now this is set up where we can, we have an equation, and now we know where our variable goes. It'll be 2x minus 96 is equal to x plus 96. Okay, so we subtract x from both sides. And add 96 to both sides to get x by itself. So this gives us x over here, and those cancel out. And this gives us, and here the x's cancel out, which gives us, let's see, 192. Okay, so that's, you have to be careful because that represents B. But it wants to know what A got. How many votes did A get initially, which was twice that. So if we multiply that by 2, we get 384. Next problem. B has $18 more than 3 times the number of dollars that A has. If B gives A $45, they will have the same number of dollars. How much money did A start with? Okay, well, let's see if we can do this with some specific numbers. So let's say A starts with $10. B has 18 more than 3 times. So 3 times is 30 and 18 more. So that'll be 48. If B gives A $45, so that gives A 55 and B 3, which clearly does not meet the condition of the problem. And if we did it by a guess and check, it may take a long time to meet the conditions of the problem. In a case like that, what you want to do is use numbers to set up the algebra. So if A starts with 10, so again I like to put a question mark over it because that tells me where the variable will eventually go. And here we don't want 30 plus 18 or 48 because we would have lost the variable. So how did we get B's? We multiplied our guess by 3 and then we added 18. Okay, now B gives A 45. So A has the initial guess plus 45 and B has what they started with plus the 18 and and minus 45. Okay, so now we have both sides equal and we know where our variable goes. So we have x plus 45 is equal to 3x, and plus 18 and a negative 45 gives us a negative 27. Okay, so if we subtract x from both sides, we get 45 is equal to 2x minus 27. Add 27 to both sides. We get 2x is equal to 72. Divide by 2x is equal to 36. And what did x represent? A's. So checking our solution now, if A has 36, B would have 3 times that plus 18, which would be 18, so that would be 108 plus 18, so it would be 126, and it gives 45 here, which would be 81, and we're subtracting 45 here, which also gives us 81. Next problem. If you want to try this on your own before looking at the solution, you can pause the video now. Here you have $11.95 in nickels, dimes, and quarters. The number of quarters is twice the number of dimes, and the number of nickels is 5 more than the number of dimes. How many quarters do you have? Okay, well, let's start by doing a guess and check. Let's say if we chose 10 for the dimes, that would make 20 quarters, and 5 more nickels makes it 15. Will that give us $11.95? Well, the quarters multiply by 0.25, the dimes by 0.1, and the nickels by 0.05. So that gives us $4 plus $1 plus 75 cents, or $5.75. Which doesn't meet our condition. And if we tried doing it by a guess and check, then it would take a long time to get that right. Well, in a case like this, though, you can still use the numbers to set up the algebra. Okay, so we start with our guess for dimes. Since quarters depend upon dimes, we'll make that our variable. Okay, and for quarters we don't want 20 because then we would have lost the place for our variable. Quarters would be double our guess for dimes. Nickels would be 5 more. than our guess for dimes. And now if we evaluate at that, so the quarters would be 25 times 2 times our guess, and the dimes would be, the value of the dimes, 0.1 times our guess, and the nickels. And all that has to equal 1195. Well, we know that's not true, but this tells us where our variable goes now. So we have, since our guess represented dimes, so that's going to be our variable. Plus, if we distribute this through, it would be 0.05d plus 0.05 times 5, which is 25. Subtracting 25 from both sides, we get 1170 on the left, and 0.5 plus 0.1 plus 0.05 is 0.65d. Dividing both sides by 0.65, we would get d is equal to 18. And you always want to take an extra second to make sure you're giving them exactly what they want. They don't want dimes, they want quarters, which is double that. So the quarters is going to be 36. So this is the last video on the SAT Math Substitution Strategy. Hope you've enjoyed it. Remember, there's no substitute for actually practicing problems. So if you go back to the first session and try some of those practice problems that where you can use the substitution strategy. The problems that I'm referring to are those in the College Board official guide, the Blue Book. In the 10 practice tests, these designate problems where you can use the substitution strategy. For example, in practice test 1, this is section 3, problem 19, section 3, problem 20, and so on.